Hi everyone! Welcome to my YouTube channel. For today's video, I'm gonna show you how to solve a geometric mean. Geometric mean is the term between any two given terms of a geometric sequence. Let's have example number 1. This is a geometric sequence. Let's say 1 and 32 are the given terms. And this in between the given terms are what we call the geometric means. So, in this sequence, we have 2, 4, 8, 16 as the geometric means. And the given terms are 1 and 32. This is the formula that we are going to use to find the geometric mean. We have a sub n is equal to a sub 1 times r raised to n minus 1. So this formula is actually the formula in geometric sequence. So we have a sub n is equal to the last term. A sub 1 is the first term. And r is the common ratio. And n is the total number of terms. Example number 2. What is the geometric mean of 2 and 18? So in this example, we will write the given. So 2, then the geometric mean, and 18. Why is it 1? Because we are looking for the only one geometric mean. So let's find the geometric mean. We will let a sub 1 is equal to 2. Since 2 is the first term, then a sub 2 is not given, and that is the geometric mean. Then a sub 3 is equal to 18, or the last term. Now, in finding the a sub 2 or the geometric mean, we will be using the formula in geometric sequence, which is a sub n is equal to a sub 1 times r raised to n minus 1. Okay, let's solve. Let's substitute the value. A sub n is equal to 18, or the last term. 18 is equal to a sub 1, and that is 2 multiplied by the common ratio. So what is the common ratio? So it is not given. So r raised to n, how many terms? So we have 1, 2, 3. So raised to 3 minus 1. Then solve. 18 is equal to 2 times r raised to 3 minus 1, and that is 2, or r squared. Okay, solve. 18 is equal to 2 times r squared, and that is 2 r squared. In getting the r squared, so we need to divide it by 2 so that the 2 will be cancelled. 2 divided by 2, then 18 divided by 2. Okay, that is 9. So r squared is equal to 9. As you can see, the common ratio here is in square form. So we need to extract the square root so that we will find the common ratio. So by doing that, we need r squared is equal to 9. So extract the square root is equal to 9. So by extracting square root, just put square root, getting the positive and negative, then square root. So the square root of r squared is equal to r. Then positive, negative square root of 9. So think a number to be multiplied by itself to get 9. So that is 3 times 3. The next r is equal to positive, negative. Since it is a perfect square, you just need to write 3 here. So r is equal to the positive and negative 3. Okay, how do we get r? the square root of r squared. So it looks like this. R squared, it is being multiplied by 1/2 or the square root. 1/2 is square root is equal to 1/2, or let's say cube root. It is by multiplying 1/3. Fourth root by multiplying 1/4. So it is how it looks like. So multiply the exponents. So we have r, 2 times 1, we will get 1 here since it is fraction. 2 times 1, and that is 2. Then 1 times 2, also 2. So 2 divided by 2 is equal to 1. So we have r is equal to 1. And we don't actually write the exponent 1. So we have r. After getting the common ratio, we need to multiply it to the first term to get the second term. So as you can see, the value of the common ratio is 2, the positive and negative 3. So we will getting first the positive 3. So first is the positive r is equal to positive 3. So the sequence is 2, then times positive 3, that is 6. Then 6 times positive 3, we will get 18. So we have the geometric mean. The first geometric mean is 6. Now let's solve the negative 3. So let's solve. When r is equal to negative 3, our sequence is 2. Then negative 3 times 2, that is negative 6. And then negative 6 times negative 3, okay, negative times negative is equal to positive. So we have positive 18. So this is our sequence, geometric sequence. And this term is the geometric mean. So we have geometric mean is equal to the positive and negative 6. Example number 3. Insert 3 geometric means between 5 and 3,125. So let's write the given. 5, and then we need to insert 3 geometric means. So 1, 2, 3, and then 3,125. So we have how many terms? Okay, 1, 2, 3, 4, 5. So we have 5 terms in this example. So let a sub 1 is equal to 5. Then a sub 2, a sub 3, a sub 4 is not given. Not given. And then we have the last term, or the a sub 5 is equal to 3,125. So we are looking for a sub 2, a sub 3, and then a sub 4. So these are our geometric means. Now let's use the formula. A sub n is equal to a sub 1 times r raised to n minus 1. So we have a sub n, or the last term, is 3,125. Is equal to a sub 1, which is 5, times the common ratio, and that is not given. Then n, how many terms? So we have 5 terms. So 5 minus 1. Then calculate 3,125 is equal to 5 times r raised to 5 minus 1, and that is 4. So r raised to 4. Then 3,125 is equal to 5 times r raised to 4, that is 5 r raised to 4. Next, divide by 5. So 5 divided by 5 is 1, cancel. Then 3,125 divided by 5 is equal to 625. Is equal to r raised to 4. R raised to 4 is equal to 625. Then let's solve for the value of r. So let's get the fourth root. R is equal to the positive negative 625 fourth root 4 and then 4. 4 is the index because it is in the fourth root. So let's solve. So cancel. R is equal to the positive negative fourth root of 625. You can actually use the calculator in this example because we are looking for the fourth root and it is very hard if we do it manually. So the fourth root is equal to positive and negative 5. So positive and negative 5. The value of R sub 1 is equal to positive 5. R sub 2 is equal to negative 5. First, we get the positive or the common ratio. So when R is equal to 5, our sequence 1 is equal to copy 5. So 5 times 5, 25. Then 25 times 5. So we have 125. 125 times 5. Okay, 625. Then last number, 625 times 5, and that is 3,125. So this is the given 5, first term, and the last term. So this or the geometric means when the common ratio is equal to positive 5. So let's get the sequence is equal, the second sequence. So we have R is equal to negative 5 when R is equal to negative 5. So negative 5, okay, let's write the first term. Then negative 5 times 5, we have negative 25. Then negative 25 times negative 5, negative times negative, that is positive. So we have positive 125. Then 125 times negative 5, different sign, so that is negative. So we have negative 625. And then negative 625 times negative 5, so we have 3,125. So these are the geometric means when R is equal to negative 5. So let's write here. Geometric means R, or positive and negative 25, then positive 125, then positive and negative 625.